Myself Baby Rani, working as Assistant Professor in MLR Institute of Technology. In today's session, we are going to discuss about Python operators. The overview of the presentation is arithmetic operators, bitwise operators, logical operators. In the later session, we'll discuss about the remaining operators. The first one, arithmetic operators. Basically, in mathematical, we will use the different type of mathematic operations. For example, arithmetic operators, plus, minus, summation, subtraction, multiplication, division, modulus, all comes under the arithmetic operators. So, the arithmetic operators are used to perform mathematical operations like addition, subtraction, multiplication. In Python also, we are performing the arithmetic operations. So, with the help of the plus operator, we are adding the two numbers. Here, x plus y. So, with the help of this, we are adding two numbers here. And subtract the right operand from the left or unary minus. So, in the unary means, we are using the only one value, only one variable here. And the next one, multiply two operands. Here in Python, we are using the asterisk symbol for multiplication. The next one, division. So, for dividing the two values, we are using the division. So, x divided by d. The x represents the numerator and the y represents the denominator here. So, the next one, modulus. So, it gives the modulus of the value. It gives the remainder of the value. So, after performing the a division b, it will give the remainder value. Sometimes it will get the zero value or some value. So, next one, floor division. Floor division is nothing but the round off value. It gives the round off value. For example, 9.3 means it will give 9. For example, if it is a 9.6, it will give 10. Floor division, it rounds off the value. So, division that results into whole number adjusted to the left in the number line. The next one, power symbol. Here we are using the for power. For exponential, we are using the two asterisks. Exponent, left operand raised to the power of right. For example, if we want to represent the 2 square, in Python, we are with the help of the two asterisks, we are performing the exponential or the power. So, 2 square. For example, if you want to write the 4 square means 4, 2 asterisks 2. So, these are the arithmetic operators we are having. So, example for arithmetic operators in Python. So, here we took x is equal to 5, y is equal to 4. So, now we are performing the arithmetic operations. The first one is the addition, x plus y equal to 19. Now, again, x minus 1. So, 15 minus 4, 11. X multiply with y. So, 15 into 4, 60. X divided by y, that is 15 divided by 4 means 4 3s are 12. So, 3.75. So, the next one, floor value. So, x divided by y. So, it will give the round of value 3. Whole number, whole round of value. X power of y we are representing with the 2 asterisks. 15 power of 4 representing with the, so the value is 50,625. So, these are the arithmetic operators we are having in the Python. So, the next one is the bitwise operators. So, any compiler does not understand the English language. It understands the binary language only. Means binary means zeros and ones. So, the bitwise operators also, the bitwise operators act as an operand if they were string of binary digits. Here, every data can be, it is a number or a character or a string. Every data can be converted into the binary form. So, for converting that, we are having converters are there. It operates bit by bit. We have to convert the data into the binary form. String to binary and the value to binary or character to binary. So, for example, 2 is 10 in binary. So, if we are taking the binary 2, we'll get the binary value is 10. So, the 7 binary number is 111. So, if you want to convert the decimal number into binary number, we have to divide that number with 2. So, for example, 7. So, I want to convert the decimal number into binary number. So, here we have to divide the 7 with 2 because binary means it contains 2 values only. So that's why we are dividing with the 2 only. So 7 can be divisible in 3 times and the remainder value is 1. Again, the 2 can be again 1 time. So the 2 2s are 1 and the remainder is 1. So the 1 is cancelled. 0 times it will cancel and the remainder is 1. So the value of it follows the bottom up approach. So we have to write the bottom to up. So the binary number for 7 is 111. In this way, we are converting the decimal number to binary number. So here in the bitwise operators, we are having bitwise AND are there. Bitwise AND is representing with the AND symbol. Next one, bitwise OR, it is representing with the pipe symbol. Bitwise NOT, so we can represent with the negation symbol. And the bitwise XOR, it is a reverse of V symbol. And the next one, bitwise right shift. So, and the bitwise left shift. We will discuss each and every one. So, the first one is the bitwise AND operator. So, the AND operator is representing with the AND symbol. So, here it returns 1 if both the bits are 1 or else 0. So, here we took A is equal to 10. B is equal to 4. So, we need to perform the bitwise AND operation. So, first we need to convert the 10 value to binary and the 4 value to the binary also. So, 10 can be, we need to convert into binary. So, it is divisible by 5, 0 remainder. And again, 2 times 1 remainder, 1 time 0 remainder. So, again, 0 times 1 remainder. So, we need to write that 1 0 1 0. The binary value for 10 is 1 0 1 0. In the same way, we need to convert the 4 in binary way. So, now we need to perform the binary AND operation, bitwise AND operation. So, here 1 0 1 0 and 0 1 0 0. So, if both the bits are 1, then only it will be true. Remaining all cases, it will be false, means 0. 0 0 means 0. 1 0 means 0. 0 1 means 0. And 1 0 means 0. So, the value is, if you are performing the A and B operation, the decimal value A and B is 0. So, if both the bits are true, then only it will be true in bitwise AND. The next one is the bitwise OR operator. So, the OR operator we are representing with the pipe symbol. So, in this bitwise OR operator, if any one of the condition is true, if any one of the bit is true, it will be true. 1 0 is 1, 0 1 is 1, 1 1 is also 1 and 0 0. If both the statements are false, then only it will be false. So, here also we need to perform the A or B. So, A or B. So, the A value is 1 0 1 0 and the B value is 0 1 0 0. So, here in the bitwise OR 0 0, false false means false only, and 1 0, one bit is true and another bit is false means true. True false true, false true true, and true false also true. So, the value is 1110. 1110. So, this is the binary number. After performing the bitwise XOR, we got the result 1110. So, here we need to convert this binary number to again decimal number. So, that is, if you want to convert the binary number to decimal number, you need to multiply that number with 2. So, the first value is 2 power 0 we have to start with, and 2 power 1, 2 square, 2 cube. So, next we have to 1 into 2 cube plus 1 into 2 square plus 1 into 2 power 1 and 0 into 2 power 0. 1 into 2 cube means 8. 2 square means 4. 2 power 1 means 2. And 0 into something 0. So, 8 plus 4, 12. 12 plus 2, 14. So in this way we are converting binary to decimal. So this is the bitwise OR operation. The next one, bitwise NOT operator. So bitwise NOT operator is we are representing with the negation symbol. Return one's complement of the number. So the formula for bitwise NOT is minus of a plus 1. Minus of a plus 1. So if you want to convert the bitwise NOT, if you want to perform the bitwise NOT means we have to perform on the single value only. So here we took a is equal to 10. The binary number for 10 is 1010. So here we need to convert we need to find out the bitwise NOT. So the bitwise NOT formula is minus of a plus 1, 1010 plus 1. So after performing, so we'll get the 1011. So here we are performing the OR operation. 10101. So 01 true, 101. So 1011 we got. So again it has the negative sign is there. So we need to convert the binary number into decimal number. Again you have to multiply with the 2 power 0, 2 power 1, 2 square and 2 cube. So 2 cube into 1 plus 0 into 2 square plus 1 into 2 power 1 plus 1 into 2 power 0. 2 cube means 8. 8 into 1, 8. 0 into something, 0 only. 1 into 2 power 1, 2. Next, 1 into 2 power 0. 2 power 0 means 1. 1 into 1 means 1. So, 8 plus 2, 10, 10 plus 11. So, the bitwise NOT operator for 10 is minus 11. The next one is the bitwise XOR operator. The XOR operator, so we are representing with this symbol. Returns 1 if one of the bit is 1 and other is 0, else returns false. Here in the bitwise XOR, if the both the statements are different input, it will be true. If the both the inputs are same, it will be false. So 1 1 false, 0 0 false. So it is the different inputs 1 0 0 1. So it will be true. So A is equal to 10. So we need to perform the bitwise XOR operation 1010 and the B value is 0100. 00 means 0 only, 10 and next one 01 and 10 111 So the 1110 is the XOR operation. In the XOR, if the both the inputs are same, it will be false. If the different inputs are there, it will be true. In the XOR operation, so in the OR operation, if any one of the input is true, it will be true. If the both the inputs are true also, it will be true. That is the OR. The next one is the bitwise left shift. So the left shift is representing with here. Shifts the bit of the number to the left and fills 0 on voids left as a result. So here we need to shift to 1. A is equal to 5. We need to convert that number to binary number. So that is the 8. So we are representing with the 8 bits. So now we need to shift. We have to perform the left shift here. So now A is equal to 5. So the binary number 5 is so now we have to fill the data 0 1 0 1. So we need to perform the left shift. Left shift means in this way we have to move. So now the 1 is placed here and 0 is placed here and again means here 1 is left shifted 1 0 and again we are moving to 1 again 0. We have to place left. We are performing the one left shift. 0, 0. So, in this empty place, shifts the bits of the number to the left side and fills 0 on the voids. Means remaining place, what is the empty place is there, we have to fill with 0. So, here the left shift on 5 is, value is 00001010. So, again we need to convert this into the binary number. In this way, we are left shifting the value. We have to move to the left side, 1 bit, or otherwise you have to left shift the 2 sides, 2 bits. In the same way, bitwise right shift also shifts the bits of the number to the right side and fills 0 on remaining places left as a result. Similar effect as the dividing the number with some power of 2. So, here also we are taking A is equal to 10. So, the binary number for 10 is 00001010. So, we need to perform the right shift, means 0, 1, 0, 1, 0, 0, 0. In this way, after performing that, we'll get the 5 value. So, we are shifting, means we have to remove one value, right shifting. So, that is the bitwise right shift. Now, we are going to the next topic, Python logical operators. So, the operators are used to perform operations on values and variables. So, we are having the 3 types of Python logical operators are there, logical and, logical or, logical not. These are the 3 operations in the logical operators. So, the value of the operator operates on is known as the operand. So, we are performing between 2 values and we are performing the operation, that is a summation or the logical and or logical or logical. These logical operators are used on conditional statements. Basically, the logical operators are used in conditional operations or the conditional statements, if conditions, else if statements, or the for loops. At that case, we are using the logical operators. If the condition is true, we have to execute this statement. If the condition is false, so like in those cases, we are using the logical operators. So, the first one is the logical AND. So, it is represented as AND. So, AND. The bitwise and bitwiser is used for on bits. Here we are talking about the logical AND, means it is used to check the 2 conditions or the 2 operations. So, the logical operator returns true if both the operands are true, else it returns false. Here, if the 2 conditions are, if the 2 statements are true, then only the logical AND will be true, or otherwise it will be false. If both the statements or both the inputs are true, then only it will be true, otherwise it will be false. So, x is equal to 5. So, one example, x is equal to 5. So, x greater than 3 and x less than 10. So the 5 value is 5 greater than 3, condition is true. 5 less than 10, condition is true. So, 1 and true, it will be true only. So, returns true because 5 is greater than 3 and 5 is less than 10. So, if both the conditions, if both the statements are true, it will be true. The next one, logical OR. It is represented as OR. So, here we are representing with the OR. Logical OR operator returns true if one of the statement is true. If any one of the condition is true, it will be true. If any one of the input is true, it will be true. So, x is equal to 5. So, x greater than 3 or x less than 4. So, the first condition, 5 greater than 3, condition is true, or 5 less than 4, it is false. So, in logical OR, if any one of the statement is true, it will be true. So, the result is true only, it returns true. The next one, logical NOT. It is represented as NOT. Logical NOT operator work with the single boolean value. Here we are using the only one value. So x is equal to 5. So the example, print not of x greater than 3 and x less than 10. So 5 greater than 3 is true and 5 less than 10 is true. True and true means true only, but before it has not of true. Not of true is opposite to the not, that is false. So the result is false. If you are saying that true means not, we are performing the logical not means it will be false. If you are saying that it is false, logical not means it is a true. It is the reverse of true. The example for logical operators in Python. So now you are taking the x equal to 2. In all cases, the x value is true and y value is false. So here I am printing print of x and y is x and y. X value is true and y value is false. So it results true and false means false only, because in AND case, in logical and if both the inputs are true, then only it will be true. So that's why x and y is false. The next one, x or y, true and false. Sorry. T or F. So if one statement is true, it will be true. Next one, not x. So we are performing for only one particular variable. So not of x. Not of x means x is true. Not of x means it results false. For example, not of y you are taking. Not of y means y is false. So it results true. So these are the logical operators in Python. So in today's session, we discussed about the arithmetic operators and logical operators, bitwise operators. In the next session, we'll discuss about remaining operators. Thank you.